Jakarta EE 10 is coming, GitHub Codespaces is becoming fast, like really fast. Dynamo DB Turns 10. There is a library that I recommend for faking data. And what the heck is the difference between Multicloud and polycloud? Welcome to episode 3 of The Artifact. This is a solo episode. It's just going to be me. We don't have a guest here that I can interview, but I have a lot of good stuff for you to share, starting with Learn from the News, a section where we are not just going to report the news, we are also going to learn from it. All right, the first item in the news for this episode is the blog post here on the Eclipse Foundation, which provides an update on Jakarta EE, like a year roundup of 2021 and what is planned for 2022. First of all, before I get into this, if any of you folks are still calling this Java EE, it's time to change, right? It's not Java EE anymore. It's Jakarta EE, okay? So Jakarta EE apparently has had a great 2021, and there have been some updates. So there is a Jakarta EE 9.1 that was released, and work on Jakarta EE 10 has started, all right? 9.1 was supporting Java SE 11, and Jakarta EE 10 has started work. It's not released yet, but there is a specific schedule that describes when that is going to go out. For some of you who are questioning why even bother with Jakarta EE/Java EE now, we have Spring, haven't we? Like, why do we even have to care about this thing? Well, Spring is one of the ways in which you can build web applications with Java and microservices with Java. Jakarta EE is yet another way. In addition, even if you're using Spring for your microservices or anything else, you might still be using Jakarta EE. See, the thing is, Jakarta EE/Java EE is a specification. It provides specification, like the standards for certain key technologies. For example, JPA is a part of Jakarta EE/Java EE. So you often tend to use JPA in Spring Boot applications. Guess where that is coming from? So that's the standard that's established by this platform. So irrespective of whether you use Jakarta EE directly to build your microservices, there is an impact by these technologies and by the specifications on a lot of other things that you do, even if you're doing this using Spring. There used to be this kind of preconceived notion that people had that Java EE at the time was too heavy, right? There's a lot of stuff involved. The server is very slow to start. So there were some obvious questions that were raised in terms of like, how can I start up such a big server when I'm building microservices? When you're building a microservice, you want the server to start as quickly as possible. And that didn't seem possible with Jakarta EE at the time or Java EE at the time. But there has been advancements over here. So this is not the Java EE of old. There are a lot of improvements. The biggest improvement that I can tell you is something called micro profiles. Okay, micro profiles are a way for you to get not only a leaner Jakarta EE server that you can start up very quickly, but it also provides a bunch of other things that you would normally need when you're building microservices. For example, there is fault tolerance. For example, there is JAX-RS, there is config, there is open tracing, there is metrics. So all of these are things that you would need to build a microservice. And people normally tend to go the Spring route because like, yeah, it's the most popular thing or whatever. But know that there is an alternative technology as well with Jakarta EE, and you can build decent microservices using micro profile. I honestly don't know the comparison between the two because I haven't used micro profile extensively, but I have heard people say that this is just as good as using Spring for microservices. It just doesn't have as much market traction as Spring has. So microprofile has had a recent update. So there is microprofile 5.0, which is the latest version at this time. And the main change that they did with microprofile 5.0 is they changed all of the package names from JavaX to Jakarta. Okay, it was earlier called JavaX, and it is now called Jakarta. That's because the name has kind of moved away from Java. If you don't know the story, Oracle was kind of managing Java EE at the time. And they said they didn't want to be like the sole owners, quote unquote, owners of Java EE. So they kind of donated that project to Eclipse. So now JakartaEE is a part of the Eclipse Foundation, but they also didn't want to have the Java name, so they've renamed it to Jakarta. But now you have all these packages in Java EE that have JavaX dot, right? So they had to rename that, and now they have renamed it to Jakarta. If you're one of those unfortunate folks who've had to migrate from using JavaX to Jakarta, there is a migration guide that I'm going to link in the description. Basically, what you need to do is bump up to the new version of JakartaEE in your pom.xml, right? Then all your imports are going to break. Then go ahead and fix your imports. And then if everything else works fine, great. If not, there might be some XML that you're going to have to deal with. So go fix those XMLs. And then if everything works great, fine. If not, maybe look at properties in your properties files, anything that has the JavaX prefix, you're going to rename that. And then there are a couple of other steps in this upgrade guide. One is rename the bootstrapping files and then verify data and dynamic content. I'm going to link this page in the description so that you can go check it out. The other thing that this upgrade guide recommends is not all things that were called JavaX before are now Jakarta. Okay, so there are some things that are still in the Java SE namespace, which were called JavaX before. Like, for example, JavaX.SQL is still JavaX.SQL. Okay, that hasn't changed. JavaX.xml is still JavaX.xml. So you can't just do a search and replace throughout. You got to be careful. Okay, so long story short, there were two flavors of Java. One is the Java Standard Edition, one is Java Enterprise Edition. Java Enterprise Edition kind of branched away from Oracle Java, and now it is part of the Eclipse Foundation, and it's called JakartaEE. And as a part of the move, the package names have changed. It used to be JavaX dot for all of those Enterprise Edition files. Now it is Jakarta dot. So they're going to have to rename. People who are using it have to rename. If you haven't been using Java EE/JakartaEE, you're good to go. Okay. And then finally, if you're worried about JakartaEE not being good enough for microservices, well, worry not. For that, we have something called microprofiles. And if you have wondered, like, what are some other alternatives for trying out these microservices, building microservices in Java, of course, there are a whole lot of alternatives these days, but just keep this in the back of your mind. There is JakartaEE and microprofiles, which allow you to build good microservices with Java. Next in the news is this blog post from GitHub, which announced that Codespaces for large repositories now have the ability to be pre-built. Well, all repositories have the ability to be pre-built, but when your repository is large, you're going to get a lot of benefit from pre-built Codespaces. Okay, what is pre-built Codespaces? Well, before that, what is a Codespace? Codespaces are a GitHub feature where you can enable a certain repository to be containerized. And then what GitHub is going to do is it's going to provide the infrastructure for you to spin up that container and code in it. And then you can also run your code inside that container, right? So it's a remote environment. It's a remote machine, virtual machine, where you can say, I want to start working on this repo, right? You browse a repo on GitHub and you say, okay, I want to start working on this. What is a normal process? Well, you're going to have to clone the repo to your local machine, and then you're going to have to run it. But then before running it, you're going to have to make sure that you have all of the software you need installed on your machine before you run your whatever repo you need, right? So it's a little tedious. However, with Codespaces, you can check in a container file, a Docker file, which has all of the things that you want in your container. And then GitHub is going to provide the infrastructure for you to run. You can specify, like, I want this particular machine with this amount of RAM. There are some presets that you can choose. And then you can say, okay, I want to start working on this repo in that thing. And then it is going to spin up a container remotely. And then your code is going to be checked out there and you can start working on it there. Okay, so that's Codespaces, which is cool already. Okay, now Codespaces have had a tendency to be slow when the repository is large. Okay, you have a large repository. When you spin up a new Codespace, it's going to have to go check out all that stuff. It's going to have to do the build. There's a whole lot of work involved there. But now you have pre-built Codespaces. Okay, what does it do? Well, basically what this blog post says is a pre-built Codespace will serve as a ready-to-go template where your source code, editor extensions, project dependencies, commands, and configurations have already been downloaded, installed, and applied. So you don't have to wait for these tasks to finish each time you create a new code space, okay? So what they will do is they will run this whole thing, right? Get the code, clone it, okay? Set up all the dependencies. If you are running like a Maven project, it's going to do the Maven install, like get all the dependencies. And, it's going to have everything ready for you so that when you spin up a new code space, it's good to go and you can actually start coding or you can start running. Okay, so the initial setup time that was formerly required for code spaces is going to be eliminated if you're using a pre-built code space. Okay, so this is public beta right now while I'm filming this. So this could be available later at some point. So definitely go check it out and give it a try if it's available to you. Next in the news, DynamoDB Turns 10. DynamoDB is 10 years old, believe it or not. I remember the first announcement that was made for DynamoDB, and it was a bit of a revolutionary thing at the time it was announced, and it's still going pretty strong, right? So DynamoDB was announced on Jan 18th, 2012. Okay, Jeff and Werner announced the general availability of Amazon DynamoDB, a fully managed, flexible NoSQL database service for single-digit millisecond performance at any scale. So this happened to be because of a certain problem that Amazon themselves faced. They were having some outages, they were having some issues, and a lot of the reason for the delays, a lot of the reason for the slow performance of Amazon happened to be because of the data. Right? They kind of traced it and they found, okay, we are having problems because the database is slow. And there were a few people there who questioned, like, okay, we are using a relational database. Why do we need a relational database for this? There were a lot of use cases for Amazon where you're showing a product. There were certain use cases where a relational database was not necessary, okay, and it was kind of holding it back, okay. One other thing that they found was the ACID guarantee for relational databases. That was a kind of the cost they were paying, right? They were paying the cost for ACID guarantees, whereas for certain use cases for the e-commerce website, they didn't need ACID. So there were a few people who went, well, if we didn't need ACID and we don't need we're not going to use a relational database, what would be the ideal database for us? And they built this kind of like key value store on SSDs, and they made it really, really fast. And the rest, as they say, is history, right? So this is the 10th birthday of DynamoDB on Jan 18th. And I am happy to wish it happy birthday. The next news item is this partnership between Azure and VMware. If you folks don't know, VMware is kind of the main stakeholder for Spring, right? Spring was under Pivotal, and Pivotal was acquired by VMware. So VMware is kind of like managing a lot of the the commercial side of Spring, or the enterprise commercial side of Spring. So Azure has partnered with VMware, and they have the Spring Cloud Enterprise offering, right? So you can actually pay them to provide support for Spring Cloud. Azure Spring Cloud is already a service that's available to you. You can kind of use Azure Spring Cloud to deploy your Spring applications. Now they have an enterprise offering where you can actually pay them to get support, right? Spring support. And they also kind of have this integration with VMware Tanzu. I haven't personally used Tanzu, but I've heard that is their build service offering. VMware has a build service offering. So they kind of have this partnership where you get supported Spring application deployments on Azure. So if you're one of those people who kind of make these decisions in your organization, you're working on Spring, your teams are working on Spring, and you are already on Azure, well, this is something that you might want to check out. This next section is titled Jargon Alert, where we're going to demystify an important term or buzzword, understand what it really means. Now, I want to give a couple of jargon explainers. In the previous podcast where I chatted with Ranga, there were a couple of terms that came up. One was something called vendor lock-in. The other was something called multicloud. I want to explain that a little bit in case you're a little confused about it or you don't fully understand what that means. Also, multicloud is something that is a little misunderstood. I want to clarify that as well. So vendor lock-in is fairly simple. You work with a vendor to deploy a service or to build a service, to build any application, you want to make sure that you're as decoupled from that vendor as possible. You don't want to tie yourself to that vendor because who knows what happens to that vendor later, right? The vendor might go bankrupt. The vendor might hate you and say, okay, this particular company is not going to deploy on my service. As unlikely as these scenarios are, especially when we're talking about these big cloud providers, it is a bit of a risk when you're kind of tying yourself to a certain vendor. So for example, you build a web application where you're using Dynamo DB, 10-year birthday, Dynamo DB as your database, okay? Dynamo DB has been around for 10 years. It's probably not going to go anywhere in the next 3 years. But for some reason, you cannot work with Amazon anymore. You cannot work with AWS anymore. Some legal complication or whatever, right? It's just some hypothetical situation. Now, what do? Since you have written code, you have your architecture that is tied to DynamoDB, you can't remove it, right? You can't refactor all your code overnight. So you are coupled to the vendor. This is what's referred to as vendor lock-in. Vendor lock-in has always been a problem, right? Even before the cloud became a thing. Vendor lock-in was related to the application servers that you built in. And that was kind of the reason why Java EE came about. There are specifications so that as long as you build to the specifications, you can kind of move across different server vendors. But with cloud, you don't have, well, you kind of have it, but not as much, right? People are still okay with locking yourself to a vendor, all right? Which is the reason why there are a few companies, really big companies, not everybody can afford to do this. There are really big companies who do something called multi-cloud. The idea behind multi-cloud is you build an application that is not locked to a certain vendor, that could potentially be deployed in multiple vendors, right? You build your architecture and so you can say, I'm okay deploying it on Azure. I'm okay deploying it on AWS. There's not a lot of changes involved. I can basically just take that app and deploy it to a different cloud. My application architecture is not aware of specific services and specific offerings of a certain vendor, okay? So this is what's referred to as multi-cloud, okay? Multi-cloud architecture is where you're architecting in such a way that you can deploy to multiple clouds, okay? This is different from another terminology called polycloud, okay? So this is a distinction that the company ThoughtWorks have published, some stuff on. So what they say as polycloud is when you have an organization that kind of takes the best solution for their problems from different clouds, okay? And in the previous podcast, Ranga does mention this. So for example, GCP is the chosen cloud provider for AI workloads, right? You're doing something AI, people normally tend to go GCP, okay? So GCP is the preferred choice for certain workloads. Similarly, AWS could be a preferred choice for certain workloads. So in this case, what you're doing is you're building an architecture where you're saying, okay, this part, well, this cloud provider is strong, so I'm going to put it there. This other part, this other cloud provider is strong, I'm going to put it there, and so on. So you're kind of picking and choosing the cloud provider for your solutions. This is not multi-cloud because each solution could be tied to the cloud provider, right? You're building AI, it could be tied to the GCP offerings, and it may not be easy for you to say, well, I picked AI earlier, I'm going to shift it to Azure because I don't like GCP, right? That's not possible if you are aware, like if your architecture is aware of the cloud. So in this case, in the polycloud case, you still have an architecture where multiple clouds are involved, multiple cloud providers are involved, but they're not cloud agnostic. They're aware of the cloud, so you can't just move it. You're still tied to the cloud. You still have vendor lock-in. So that's an important distinction to make. So just something to keep in mind when you're thinking about these architectures. Multi-cloud is where you can be like, hey, I don't care if this cloud goes under. I'm going to go shift to another cloud provider, right? You can move and shift around and all that. You're not tied. You don't have vendor lock-in. Whereas polycloud is where you have an architecture where multiple clouds are involved, but there could still be vendor lock-in in each of those interactions with the cloud, okay? Multi-cloud is something that is not very common because it is very, very expensive to do multi-cloud. It is easier and cheaper to go with vendor lock-in and say, well, I don't care if this cloud provider goes under, I will be able to shift to something else and, just do refactoring, whatever is necessary at the time, rather than starting at the outset and saying, I'm going to have to put these extra layers and extra precautions to make sure that this thing works in every cloud provider. It's very, very expensive. And only large companies and companies that really have the need for okay, I want to be completely decoupled. The risk is too high if I'm attached to a single cloud. Only those kind of companies do multi-cloud. It's not common. Okay, so just something to keep in mind. Our next segment is titled Read This Thing. I'm going to share with you things that I have read. I think you should read. Okay, in today's Read This Thing, here is a AWS solution implementation guide for something called AWS Virtual Waiting Room. I'm not kidding. This is a waiting room for websites. It doesn't make sense, but go with me here. The idea is when you're building an application where you have a possibility for getting large bursts of traffic, and you don't want to scale and handle the traffic, you want to streamline the traffic and control how people enter your website, you can provide a virtual waiting room. Okay? This is useful in certain situations where you do have the need for transactions and you do have the need for kind of controlling how many people can make a transaction or can visit your website. Here are some examples that AWS provides. So sale of concert or sporting event tickets, at least at the beginning, okay? So new product launches, fire sales, okay? Class attendance. So these are cases where you want to control how somebody transacts with your application. For example, if you have an e-commerce website, more people come in, the merrier, right? You don't care. You want it to scale as much as possible. But when you're selling concert tickets, you don't want scammers to access your website. You don't want bots to access your website. You want to somehow control and limit what the incoming traffic is. For that, this is a great solution, AWS Virtual Waiting Room. And if you're not familiar with this kind of implementation guides, what they do is they provide a best practice of how to implement something. And then they provide what are the AWS resources that are necessary for you to implement it in your application. Okay. So this is, so there are some benefits. First of all, there is a structured queue here, right? Users are assigned a queue number when they enter the waiting room. So if there is a long queue, they have to wait. Okay. So there will be this web page where they see, okay, you are person number 200. You're going to wait. And it's not going to be like an in-person queue where, 200 means you're going to get service in 2 days time or 3 days time, right? You're calling the doctor's office and the automated system says, you're caller number 200, you just hang up. But with websites, the numbers are high, but they typically tend to move faster as well, okay? So people are assigned a queue number and they maintain the position in the queue and only leave the waiting room to enter the target site when it is their turn, okay? So they maintain the position. If somebody goes and comes back, the solution still remembers you. Okay, you are queue number 200. Now we are queue number 20 and so on, okay? So it offers scalability. That's one way to scale, right? Quote unquote scale. If you feel like your infrastructure cannot handle the kind of a load that's coming in, you can say, well, I'm going to put people in a waiting room and I'm going to gradually stream people in so that my infrastructure can handle the load that's coming in. Anything beyond that, you're going to just keep people in the waiting room, right? It protects downstream systems, which is kind of take that buffer for the load. Standalone integration, or you can use OpenID for this. And the solution has a sample waiting room to demonstrate the end-to-end waiting solution. If you're working on an application which requires this kind of a solution, here is an interesting idea. Whoever thought there is a queue for getting into websites, okay? There is a good reason to do it for certain use cases, not for all. If you feel like your application should be able to scale, don't put a waiting room in there, just scale your infrastructure, right? If you feel like you need some kind of semblance of sanity in terms of how people are getting to your website and using your website, well, this is where you would provide it so that you kind of streamline that. The next segment is titled Featured Library of the Day. This is a library that I think you should check out. Today's featured Java library is something called Data Faker. Right? So this is inspired by a JavaScript library that I have used multiple times called Faker.js. That's also a library that has had a bit of controversy lately, which I'm not going to get into in this episode. but this data faker is the Java side of things. Now, what is data faker? Data faker allows you to create fake data. It's as simple as that. So let's say you're testing an application and you want to have like 100 different employee records, right? You have to come up with unique employee names, employee ages, addresses, all that stuff, phone numbers and all that stuff. Well, one way to do it is to just put one email address, one name, one phone number, repeat it 100 times. But first of all, it doesn't look good when you're testing it, and you just keep seeing the same thing. And it's not close to what a real data would be. So what this allows you to do is just generate fake data, okay? And it kind of looks like real data. So the way it works is you add this dependency to your build system, Maven or Gradle or whatever else. And here is the usage. You want to generate a few first names and last names. Here's what you do. You import a faker class, and then you call methods on it. You say faker.name.full name is going to give you a full name. Faker.name.first name is going to give you first name. Faker.address is going to give you the address, and so on, right? So it's the names are going to be like real names, okay? So the first name example could be Emery, and the last name example could be Barton. Okay, these are real names. They look like real names. The addresses look like real addresses. So if you want to just generate a bunch of fake data, just put this in a loop. Now we have random data. This is great for tutorials as well. You're writing a tutorial or you're writing a demo or something like that. You want to present a demo. But rather than come up with convincing fake data, just use this thing and it almost looks like you have real data in there, right? There's a lot of stuff involved here. And, Data Faker has this model of plugins, okay? You can add plugins or data providers as it is called. All these different data providers. There's a data provider for address, which renders addresses, right? Fake addresses. There is a data provider for barcode, which allows you to generate fake barcodes. And there is some fun stuff as well. There is a provider called Back to the Future in the data providers page. I have no idea what that does, but maybe you should check it out. So there are lots of data providers that can plug in and generate fake data. For example, there is a data provider for Pokemon, which allows you to generate Pokemon names and locations. So this is the Java library of the day for you to check out if you find this interesting. Okay, so with that, we wrap up episode 3 of The Artifact. A lot of good stuff that I shared with you. Hope you found this useful. Make sure you have subscribed to this podcast in your favorite podcast platform, and go to theartifact.io if you want to learn more about the podcast, see previous podcasts. And if you want to be a guest on this podcast, if you want me to interview you, you want to interview me, there is a link on theartifact.io that allows you to register as a guest. So go ahead and register and let me know what you want to talk to me about. And I'd be happy to reach out to you if I find it interesting. So give it a go. Thank you for listening, and catch you folks in the next episode.